grade into math lesson 6.1. Represent fractions, sums, and differences. I can make a visual model to represent the addition and subtraction of fractions with different sized parts. Spark your learning. 4 hikers traveled along the same trail over 2 days. The fraction of the trail each hiker travels is shown. Okay, so use the data in the table to show 2 ways to represent the fraction of the trail one of the hikers travels on both days. Okay, so a lot of times we can use manipulatives sometimes to try and work out our problems, right? Okay, so let's do James. Okay, so if we're going to represent him, he needs a fraction bar. Okay, so 1 whole fraction bar, okay, would represent 1 whole mile, right? Let me make this a little bigger. Okay. So this would represent 1 whole mile, right? Okay. So on day 1, he goes how far? Half a mile. Okay. So we're going to draw a box right below that. And then this is only 1/2, right? This is only 1/2. Okay. Then on the second day, he goes how much further? 1/4. Okay. So is 1/4 the rest of this? No, it's only half of the half, right? Okay. So we can do that. Now, if I would go to add those, could I add them exactly like they were? No, because if I wanted to add 1/2 plus 1/4, I need to get a common denominator. And in this case, what is my common denominator? 8. Or, yeah, we could do 4. Okay. So, how do I get from 2 to 4? Times 2. So what I do on the bottom, I do on the top. Okay. And then this one would stay the same, right? And we would get 3/4. So technically, if I wanted to find this with my fraction strips, I'd have to turn in the 1/2 for what? 2 1/4 pieces, right? And then I would still keep my 1/4 pieces. Okay. Now, if we did 8, we could still do that, right? But we would get 6/8, and then we have to simplify. Yes. Okay. So by just using the force, that put it into simplest form already. Building understanding. Marley and Jackie saved together to buy a tent for their camping trip. Marley saves 3/8 of the cost of the tent. Jackie saves half of the cost of the tent. How much do Marley and Jackie save toward the cost of the tent? How can you represent the situation? Draw to show your thinking. Okay, so they need to get a whole total, right? Okay, so that would be represented by our 1 fraction bar, right? Okay, and then which one would be easier to show first? Marley's or Jackie's? Jackie's, right? Okay, so we can put half, right? And this is Jackie, okay? And then Marley has, so for the rest of this, Marley has what? 3/8. So how many 8 are in the other half? 4, right? So we're going to break this into 4 pieces. Okay, and you guys told me that there were 4 8s there to make a half. Okay, and then let's see. And then how many of those 3/8 does Marley have? 3, right? So if I kind of lightly color those 3/8 in, how much do we have left then? we have this 1/8 left that they still have to get the cost of the tank, correct? Okay. Letter A. How did you combine the 3/8 and 1/2 to help you find how much Marley and Jackie saved? Explain your thinking. So we came up with a what? A common denominator. Okay. So we came up with a common denominator. Of 8, which got us. So if we have 1/8 left, how much do they have already collected? 7/8, right? 7/8 of the cost collected. Okay, and then on B, it says to write an equation to model your solution. So we know that they had 3/8 plus 1/2, right? So what did we say our common denominator was? 8, right? So 3/8 can stay the same, but this has to become an 8, right? Okay, so how did they get from 2 to 8? Times 4. What I do on the bottom, I have to do on the top. So 3/8 plus 4/8 is 7/8. Number 2, Pedro takes half a pound bag of trail mix on his hike. During the hike, he eats 1/4 pound of the trail mix. How much trail mix does he have left? How can you use fraction strips to represent the situation? Draw to show your thinking. So, would we need the one whole piece this time? No, we only need a half, right? So we draw one box, and then it represents a half, right? Okay, and then he eats 1/4 of a pound, okay? So what would be our common denominator between 1/2 and 1/4? 4, right? Okay, so how many 2/4 pieces, how many fourth size pieces does it take to get 1/2? 2, right? So to get 1/2, it takes 2 1/4 size pieces, correct? Okay, so he ate 1/2 of it, right? So if we shade this in, he's eaten that 1/4, right? Okay, so how much does he have left that he could eat? 1/4, right? So what size fraction strip pieces can you use to represent the amount of trail mixes he has left? So we said 1/4, right? Okay, and then write an equation to model the amount of trail mix he has left. What is the amount? So we said that we would do 1/2 minus the 1/4, which 1/2 also equals what? So this also equals 2/4 minus 1/4, which equals 1/4. What's our label? Pound, right? Our answer is 1/4 pound. Check understanding. Claudia starts at the nature center and walks 1/2 mile along a trail to this signpost. How far is the waterfall from the nature center? So, how can you use fraction strips to represent the distance from the nature center to the waterfall? Okay, so in this case, we would need to go ahead and put our whole piece, right? Okay, so we'd have our whole piece of 1, right? And how far does he walk to begin with? The 1/2 of a mile, right? So this is represent 1 full mile, right? And then we need to show 1/2 a mile, so she's walked 1/2 a mile. Okay. Then, how far is the signpost? 1/12, right? Okay. So we need to add in that 1/12 here. Okay, so we need to know how far she's walked. Now, how many 1/12 size pieces go into 1/2? 6, right? Okay, so we would show that this is, so we need 6 little sections here. So, and these are 1/12. And then we still have this extra 1/12, right? Because that's how far it is to the signpost. All right. So how many total 1/12 pieces do we have? 7. So there's a total of 7 12. Okay. So if we write an equation to show that, we would do 1/2 plus 1/12 equals 7/12. But if we got a common denominator, we said 1/2 is also equivalent to how many 12? 6, right? So 6/12 plus, oh, no, 7, sorry. 1/12 equals 7/12. And what's our label? Mile, right? On your own, model this method. Luna hammers a stake into the ground for her tent. She stakes 7/8 foot long, or the stake is 7/8 foot long. She hammers the stake 3/4 foot into the ground. How long is the part of the stake that is above ground? Okay, so draw to represent your problem. Write an equation to model the solution. Okay, so first of all, what would our pieces be? We need our hole, right? But are we filling up that hole? No, we're only doing 7 pieces of it, right? So we can go ahead and draw a hole and then break it into 8 pieces. But we're only going to use 7 of those pieces, right? Okay, and then like we said, we're technically only using these amount of pieces right here, right? Okay, now if I were to do 4s, I could break a hole into 4 pieces, right? Okay, and how much did we use for that? 2. Okay, so we could use 3 of them, right? So just 3 of them for this. Okay, but was it the 3/4 of the whole though? Or was it the 3/4 of the 7/8? Okay, so technically we should have only done this to go to the 7/8, right? Okay, so I just wanted to show you it wasn't of the whole piece, it's of just the 7/8 part. So we should have technically only drawn our piece to here, right? Okay, and then broke this piece into 4 pieces. And then these are 1/4. And then all they did was they only used 3 of those pieces, right? So they used up 6/8 of it, right? So how much is left over? Just the 1/8, right? So 1/8 foot, right? Okay. So basically, so then if 1/8 is above ground, how much is below ground? Did it say? 3/4, right? Okay. So basically, we did what?